Good morning, one and all present here. So we are here to have a great lecture based on the network, signals and system. So what is network is? Network is you will have say different components involved in it. So we will have R, L and C components. So signals is all the signals that we transmit, and system is the signal on which the system works. That is what is a system. So I am here to deal with transient analysis of the circuits. So it is nothing but either you can have a combination of your resistor, capacitor or resistor inductor, or combination of all the three, resistor, capacitor and inductor. So when we have the when we go for the transient response, so we would be having about the transient response. So transient response is nothing but it is with respect to time. So when we go for transient means it is a time domain analysis of any signal that is being sent. So here we will be discussing about the transient analysis of different components involved in a system. So we have three components. One is a resistor, capacitor and an inductor, as we all know. So resistor, you know that it resists the flow of current. So it will not store energy in any forms. Whereas when we go for capacitor, it is used to store the charges in it. We all know that it is a two-plate structure, so it will be able to store the charges with it. And then we have an inductor. So in what way this capacitor will store the charges is nothing but it will store it in the form of voltage. And when we go for the inductor stores the charges in the form of the magnetic field. So this is what is about the basics of what is R, L and C. So when we know about all these things, we would be able to tell when it has a switching and when it does not have a switching. That is what we are going to know about in the forthcoming videos. So we will continue some of the problems in the next. So as we have discussed about the basics of the R, L and C. So what R does, what L does and what C does. So here we have the components placed. So since it is a time domain approach, we are going to vary the function with respect to the time. Okay. So in the time domain, I am giving a signal, say I am giving a say the current. So the current is given as I of t. So it is varied with respect to the voltage V of t. So first is your resistor, then I have drawn it for inductor and then for your capacitor. So when we have like this, so next is we have to make use of this I of t with respect to the R, and next is I of t with respect to my inductor and I of t with respect to my capacitor. So when I have like this, I can say that my V of t is given as the current that flows across a resistor, because resistor is going to oppose the flow of current. So that is what is V of t is equal to R into your I of t. Next we have the inductor. So inductor is V of t will be equal to L into di of t divided by dt. This di of d divided by dt is nothing but the range of, that is the rate of change of current with respect to the time. So rate at which the current changes, that is called as di of t divided by dt. Next is your capacitor. So capacitor, it's as I said you in the previous video, it is going to store the charges in it. So that is the voltage that it is going to store. So that is why we have written I of t is equal to C into dV of t divided by dt. So this is what is about the explanation of the equation that I have written here. So here when you see for transient analysis, so here you have the time domain. So in time domain, when I say t is equal to 0, that will be called as your switching time. So this switching time when t is equal to 0 is called as a switching time. So when I have say t is equal to 0 plus is called as this indicates switching. T is equal to 0 plus indicates that it is just after switching. Similar way, when I have t is equal to 0 minus indicates just before switching. So we have the conditions say like this. Okay. So when I have say t is less than 0, what happens, and t is greater than 0? When your t is greater than 0, it says that it is just after switching. In terms it says that it is after switching. And similarly, when you have your t to be less than 0, it says just before switching. We'll name it as before switching. That is what is going to happen. And when I have say t is equal to infinity, then I say that it is under steady state condition. So these things should be known when you do it with respect to time domain. That is your analysis of R, L and C to time. So time conditions you should be knowing. So this is our initial time. So when it operates, suppose say a resistor carries resistor allows, that is it restricts the flow of current, and whereas when you see inductor, it is going to allow some amount of current. You say suppose I allow 4 amperes of current to flow through the inductor. It is already flowing, it is already allowing 4 amperes of current to flow through it. But suppose when it instantly changes to 10 amperes, it will not allow at that particular time itself. Suppose say an inductor is already, it has a 4 amperes of current, but it allows again 2 amperes of current to flow through. What will happen is it will not affect this 4 amperes current. It will take some amount of time to have a transient from 4 to 2 again. So that is called as the transient time analysis. Is it clear? So this will be known as your transient time analysis. So we will have some problems to be dealt with this in the next session. So as we have already discussed about the R, L and C components. So here is the R, L and C and how it varies with respect to time. So I told you about the instant time and what about the steady state time and how it does the switching before and after switching. So these are all about this slide. Next is we have some problems related to that. So you have an voltage source of 2 volt which is applied to 1 ohms resistor and again 1 ohm in parallel and 1 Henry. So when I say this diagram, I have to find a transient response of this diagram. So what it tells is that you have to find out the transient time. So I am giving an initial of 2 volt. So before that some volt will be flowing in the circuit. So what is the time that is required for it to switch from that voltage to 2 volt? That is called as the transient time. So here we are going to find out the transient time. First thing that you have to do is with respect to R, L and C, my tau that I calculate should always be equal to, say, what is your R equivalent that you calculate divided by L, or it can be R into C. It can be of any 2 things. So either it can be R equivalent by L when you have it as an inductor, it is R equivalent into C when you have it as a capacitor. So here first is this voltage source I have to short the voltage source. As we all know that any voltage source when you want to find an R equivalent, you would have found R equivalent with the help of Thevenins and all. So Thevenins, what we do is we would short circuit this voltage source. So the voltage source is short circuited. So when I have a short circuit of this voltage source, I will be short circuiting the voltage source. So this will not be available, so it will be a line. Okay. So next I have a resistor and this. So at this point I am going to calculate your R equivalent. So when I calculate R equivalent, what is that? At this junction it flows and it gets divided. So I can say that it is 1 parallel with 1. Yes. So 1 into 1 divided by 1 plus 1. So it is 1 divided by 2. Is it clear? So I have a resistor value that is R equivalent is equal to 1 by 2. And your Henry, that is your L. L is again 1. So what is the tau that I can calculate now? So it is tau is equal to R equivalent 1 by 2 divided by your L. That is nothing but 1 Henry. So 1. So it is 0.5 seconds. Is it clear? Yes. So you would be having here, first when you have an voltage source, I am short circuiting it. Then I am calculating an R equivalent. Here I have 1 resistor along with 1 resistor. So 1 resistor parallel with the 1 resistor. So that will give my R equivalent. Then an inductor value I have used. So inductor value is 1. So I have found tau with respect to that. That is nothing but R equivalent divided by L. So which is equal to 0.5 seconds. So this is what is about the transient time. So transient time indicates this supplied voltage. This is your 2 volt is your supplied voltage. Before that, 1 voltage will be flowing across the circuit. So what is that voltage? Well, that voltage is flowing across the circuit. So what is the time that is required to switch from that voltage to 2 volt? That is called as your transient time. So it takes 0.5 seconds. So we will move on to the next problem. So next problem, when you see, so I had an voltage source, but here I have a current source. So current source, similar resistor values you have. So current source with the voltage, I have to find out the transient response time of this with respect to the current source here. So I have 2 amperes of current flowing across. So similar way, when it is 2 amperes, what will I do? So I have to short circuit the current source. So here I have done a short circuit of that. Here voltage source has to be open circuited. So when I open circuit, this terminals will be left alone. So what happens to the resistor? This I will not take into consideration. Next is 1 ohm resistor and 1 kilo ohm. So it is tau will be equal to R equivalent divided by L. So that is 1 by 1. So it is 1 seconds. Is it clear? So this is what is about. So whenever you have an voltage source, you short circuit. Whenever you have a current source, you open circuit. Since I have open circuited, no current flows across this resistor. So it is not taken into consideration. I take this and this. So this is my R equivalent and this is my L. So R equivalent divided by L, which is equal to 1 by 1, which is 1 second. So this is what I want to make you understand about the L, and when you have R and L elements in the circuit. So we would continue with respect to different elements in the next slide. See, as we have discussed about R, L and C different components, so how it changes with respect to the rate of change. So whenever say, for example, I told you that whenever an inductor have the value of say, suppose 2 amperes of current flow through that, okay, and again you want to indulge 1 ampere of current forcefully into that. So what happens is that 2 ampere of current, it will take some amount of time to rectify from 2 amperes of current to 1 ampere. So this time taken is called the transient time. So that we would be calculating with respect to 2 things. One is whether it is an RL or an RC circuit. So when it is an RL, you calculate it as L divided by R equivalent. When it is an RC, you calculate it as R equivalent into C. Okay. So these are the 2 formulas we will be making use of in order to calculate the tau. So tau is the transient time. So for example, this is our first problem we are going to discuss. So here I have a resistor, I have an inductor. So this circuit is RL circuit, and first is that you have to find out. After that you are going to find the transient time of this. So I want to find the transient time. I should find what is the R equivalent. First is what is tau. Tau is given by L divided by R equivalent. So when I have it as L divided by R equivalent, so I have to calculate what is the R equivalent. So we know that using Thevenin's we would have calculated R equivalent. So what is the first step of Thevenin's? You know, as you all know, first is you have to, if it is an voltage, you have to short circuit. If it is in current, you have to open circuit. So here we have an voltage source. So voltage has to be short circuited. So when I do a short circuit, nothing will be there. So you will have an voltage source short circuited. Next is you have to find the R equivalent across this end. Yes, so when I have to do that, so this one is parallel with 1 again. So I can write it as 1 cross 1 divided by 1 plus 1. So it is 1 by 2 is my R equivalent. What is my L? That is 1 Henry. So when I have it as say, you have to calculate tau. So when I have to calculate tau, so how can I calculate? It is L by R equivalent. So what is the value of L here? L is 1 divided by R equivalent is what? We have calculated by short circuiting the voltage source. That is nothing but 1 by 2. So can I write it as 2 seconds? So this is the answer for this. So this transient time. So this is what? This is a transient time. So when I want to find a transient time is nothing but this is a 2 voltage that is applied. Already some amount of voltage is being applied to this circuit. So what is the time that is required to switch from one voltage to the other or one current to the other? That is called as the transient time. So I'll move on to the next problem. So this is our second problem. So we have a current source, we have a resistor and your inductor. So resistor and inductor, I can represent it as say, it is a circuit that is consisting of R and and L. So I can write it as RL circuit. Next is, this is a current source. So when you have a current source, when you want to find the R equivalent, the R equivalent is calculated across this end, right? So this R equivalent, when I want to calculate, what should I do is, I have to open circuit the current source. So when I open circuit, this will be like this. So there will be no current flowing across that. So what will happen is, the resistor, you will not have any current flowing across the resistor. So this current source is only applicable to this. Yes. So the current source is not available. So it does not flow through the resistor. So 1 ohm is the resistor you have. So what is the R equivalent? It is 1. This is L. So tau can be calculated as how? It can be calculated as L by R equivalent. So your L is 1, R equivalent is 1. So it is 1 second. So this would be our transient time that we have calculated. So we would continue the next, we would continue few problems on this. So as we have discussed about 2 problems, this is a third problem where we have R and your L along with so much of resistors are there, so much of inductors are there. So this is again a current source. So when I have a current source, what do? I do an open circuit of the current source. So open circuit in sense, this is open circuited. So no current flows across 1 ohm resistor. So again you have 1 ohm resistor along with 1 Henry along with 9 Henry. So I can move this to this side and this to this side. So what happens is, 1 along in series with 9. So I have 1 and 9. So what is the R equivalent that I calculate across here is, R equivalent will be equal to 10 ohms. Next is, you have to calculate about the Henry. So Henry here is, say this is 2 Henry and this 2 Henry. So this 2 is parallel in width 2. So I can write it as 2 cross 2 divided by 2 plus 2. So it is 4 divided by 4, which is 1, and along with that I have 1 more Henry. So when I have 1 more Henry, so I can write it as 1 plus 1, so that is 2 Henry. So I have the R equivalent, I have the Henry value. So I can calculate tau as L divided by R equivalent. So what is the L value? So L is 2 divided by my R equivalent is 10. So I can write it as, it is 1 by 5 second. So the value that I calculate for tau is equal to 1 by 5 seconds. So this is what is our calculation. So first is what we do, we have a current source. So when you have a current source, you are going to open circuit. Instead, if you are going to have an voltage source, you are going to short circuit it. So if I have suppose voltage source, so what will you do? This you will be short circuiting it. So current will flow across this. So this is again 1 in parallel with 1. So you will be calculating as that. Okay. So as that proceeds. But here you have a current source. So current source is what? Current source, you have to open circuit. You open circuit, you find out R equivalent and you find out what is the L. So after that you substitute in tau, it is L by R equivalent. So your answer will be 1 by 5 seconds. Next, one more problem we have. So with this, we have an voltage source here. So here when you see, it is an voltage source. So I have the resistor values as R and 2R. Similarly, I have it as C and 2C. So this is an voltage source I have. So here is a voltage source. So voltage source, what do? I do an short circuit of the voltage source. So I short circuit this voltage source. So I have one resistor and 2R resistor. So these two resistors are connected in parallel. Since there is no voltage across this end, so these two resistors are connected in parallel. So I calculate R equivalent from this. So what is R equivalent? So R equivalent is R parallel with 2R. So I can write it as R into 2R divided by R plus 2R. So it is nothing but, it is 2R into R divided by 3R. So this R and R will get cancelled. So it is 2 by 3 R is my R equivalent value. Then I have a capacitor. So capacitor is, one is C and other is 2C. Similar way, capacitor is also parallel in connection. So I can write it as C into 2C divided by C plus 2C. So it is nothing but 2C square divided by 3C. So I get cancel of this one C. So it is 2 by 3 into C. So this is my C. So this is my R equivalent and this is my C. So how would I calculate tau from this? So tau is R into C. So what is R value? It is 2 by 3 into R into C is what? C is again 2 by 3 into C. So what is your answer? Our answer is 4 divided by 9 into RC. So this is nothing but this is a transient time the system takes to change from one voltage source to the other voltage source. So since this is all written in R and C, we have the answer to be as in R and C. Thank you for listening to this transient analysis, and we would continue that in the forthcoming session.